In this video, we'll discuss about locks. So a lock is a thread synchronization mechanism like synchronized block, except locks can be more sophisticated than Java synchronized blocks. Lock is an interface in Java, and therefore we need to provide an implementation, our own implementation, or we can use one of the implementation which is being provided by Java. Since lock is an interface, we need to use one of its implementation to use locks in applications. Reentrant lock is one such implementation of lock interface. Difference between lock interface and synchronized keyword. The main difference between a lock and synchronized keyword block are: synchronized block does not provide a timeout. Using log.trylock, long timeout, time unit, it is possible. So we have seen in the previous implementation that when we have the synchronized block, we can have deadlocks. In order to avoid the deadlocks, synchronized block does not have a timeout value. So in this case, what we can do is that we can use lock instance and log.trylock with a timeout value to avoid the deadlock issues. The synchronized block must be fully implemented in a single method. A lock can have its call to lock and unlock in a separate method. So if your program requires that you must be unlocking in a separate method, then use locks. Otherwise, synchronized block is capable of the same functionality which lock provides, other than timeout. Reentrant lock. Reentrant lock allows thread to enter into lock on a resource more than once. When the thread first enters into a lock, a hold count is set to 1. Before unlocking, the thread can re-enter a lock again, and every time hold count is incremented by 1. For every unlock request, hold count is decremented by 1, and when the hold count is 0, the resource is unlocked. Reentrant lock also offer a fairness parameter by which the lock would abide by the order of the lock request. When the thread unlocks the resource, the lock would go to the thread which has been waiting for the longest time. This fairness mode is set up by passing through to the constructor of the lock. Reentrant lock methods. The first method is lock. So call to lock method increments the hold count by 1 and give the lock if the shared resource is free. You can call lock method multiple times, and every time the hold count is increased by 1. Unlock. Call to unlock method decrements the hold count by 1. When this count is reached to 0, the resource is released. Try lock. If the shared resource is available, the try lock will lock the resource and increment the hold count to 1. If the shared resource is not available, it will exit instead of waiting. So the main difference between try lock and lock is try lock will exit if the resource is not available, but the lock will keep waiting for the lock to be obtained. Try lock, long timeout, the time unit. The thread waits for a certain amount of time specified as a parameter before exiting if the shared resource is not available. Lock interruptibly. If the thread is waiting for a lock, but some other thread requests the lock, then the current thread will be interrupted and return immediately without acquiring lock. Now let's look into the implementation of one of the program with locks using IntelliJ. In the previous section, we looked at an example of bank account transfer where we were transferring money from student bank account to university bank account. We'll be extending this example using locks, and we'll be adding some more new functionality in this example like executor service which run threads. So in order to implement this, let's click on com.modern.java.threading and create a new class, new Java class. And the class name is bank transfer. So what is the state of the bank transfer? First one is balance, so private double balance, and the second state is ID, so private integer ID, and the third state is the name of the account, so private string account name. And we'll be creating a log implementation using reentrant log. So final log is equal to new reentrant log. Now let's create a constructor for this bank transfer, which is public bank transfer, and here we'll be passing on the attribute ID double balance and string account name. And this dot ID is equal to ID, and this dot balance is equal to balance, and this dot account name is equal to account name. Now let's create a withdraw method. So public boolean. So here, so one rule of thumb, whenever you are doing with try log, you might want to have a boolean variable return from the method, because you will be going in a loop. If you are unable to get the try log, then just go in a loop until you get the try log, until you get the log. So, and with synchronized method, you don't have to do that boolean, because in synchronized method will synchronize block will definitely wait for log to be obtained. So withdraw and double amount, and here the first thing what we'll do is that if this dot log or try log, if we are able to get the log, then thread dot sleep to mimic the behavior of database, and balance is equal to minus plus is equal to amount. Balance is equal to balance minus amount, and afterwards we will just release this log and return true. Here is complaining about the sleep, so let's add exception to method signature. And here return false. Now let's implement the deposit, public boolean deposit double amount, and again we'll be trying to get the log, this dot log dot try log, and again thread dot sleep 100 and balance plus equal to amount, and this dot log dot unlock and return true. Here return false. Now let's create a transfer method. Public boolean transfer, and here we will have bank transfer to, because this class will be used as the from, and double amount. If withdraw amount, then print out withdrawing amount plus amount plus from plus count name. And if to dot deposit, then print out depositing amount plus amount plus 2 plus 2 dot account name. And then return true. So if it's able to withdraw and deposit, then return true. Else south fail to acquire both the locks, refunding plus amount to plus account name. So if it's unable to attend the lock, because we already have done the withdraw, so we'll have to refund the amount to the from account. And while going up, while not of deposit amount, continue. So what we are doing in this case is that first withdraw. So the lock is obtained from here till here. So this curly braces. First get the withdraw lock, and then get the deposit lock on the deposit. If you are able to get the lock on deposit, that's fine. Depositing amount. Print out a deposit amount and then return true. If you are unable to get the lock on deposit, then continue on forever to get the deposit. And after every time, this print out failed to acquire both locks. And then return false over here. This complaining about add method signature. Here I missed out. And now implement the main method. So PSVM, create the main method, and inside the main method we'll be creating instance of bank transfer. The first instance is student bank account is equal to new bank transfer, and ID is equal to 1. Let's say student have a balance of 50,000 and account name is student 1, student A. And then bank transfer, university bank account is equal to new bank transfer 1, and let's say university have a balance of 100,000, and the name of the account is university. And let's print out the initial balance of both the accounts. So starting balance of accounts are university plus university bank account dot balance plus student bank account dot balance. Now here we'll be creating an executor service. Executor service is a service which runs threads, because we'll be running this in like 10 threads. So we need a service, otherwise creating those 10 threads is a lot of work. So that's why we'll be using executor service. We'll be talking about the executor service in the next sections. But for the time being, just look at the syntax, and syntax should be very clear. So executor service is equal to new, or is equal to executors dot new fixed thread pool. So we are running a thread pool of 10 threads. So this is a thread pool of 10 threads. It won't go above 10 threads. We'll be running 20 threads. So when the first 10 threads is done, then the next thread will go in the executor service. So it will be running maximum of 10 threads. And now let's create a thread T to do a transfer, and equal to new thread and here I'll be printing out using South thread dot current thread dot get name plus says executing transfer. Now while not of student bank account dot transfer and to university bank account, and the amount which will be transferring is $1,000. Here we'll be sleeping the thread for 100 milliseconds and continue. So while it is waiting for the transfer to happen, the thread will sleep for 100 milliseconds and then continue. Complaining about unhandled exception. So let's do a try catch over here. Try and then catch. Interrupted exception, IE, and IE dot print step trace. Let's close this out, and then we have our thread implementation completed. The only other thing which you want to print out over here is transfer completed. Is thread dot current thread dot get name and plus say transfer completed. Transfer is successful. So it will come over here, it will wait for transfer to be completed. Once the transfer is completed, it will print out transfer is completed. Now we'll be running a loop of integer I is equal to 0 and submitting this thread through that loop to the executor service. Service.submit T. Now we'll be shutting down the service, setting the service dot shutdown. So there is one thing which we need to do at this end is that because there might be some deadlock, because the threads might be having some deadlock, so what we need to do is that we have to shut down this service after some time. So let's implement that block also. So while not of service dot await termination, if the service is live, so within 24 hours, after 24 hours of time unit dot hours, so then not yet, still waiting for termination. And let's do a try catch. Catch, and we'll throw interrupted exception. And e dot print stack trace. Now let's look into this method. Implementation, go to implementation, thread pool executor. So this method basically says that it will wait for the termination and will automatically terminate after 24 hours, which we have defined, which I have defined as the timeout for this one is 24 hours. And at the end, let's print out the balance. So ending balance of the student account plus student account dot get balance or dot balance and plus university account plus university dot balance. Thread dot sleeps unhandle exception, add exception to method signature. Okay. Is there any other error? No. So with this, we are done with this program. So here, so let's go through this program here from executor service. So we are starting executor service with the thread pool of 10. Then we are initiating the transfer from the student bank account to transfer to the student bank account to the university bank account, and every time we are doing a transfer of $1,000, and we are submitting this transfer request 20 times. So at the end, 50,000 minus 20,000. So at the end, the student balance should be 30,000, and the university bank account balance should be 130,000. Let's run this program. So you can see that starts from here. So it's basically start executing the transfer for those 10 threads first, because they are the thread pool of 10. So first 10 threads are lined up for transfer, and every thread is withdrawing money, and then fail to acquire both locks, refunding, and then say transfer is successful, executing transfer, withdrawing, depositing, and at the end all those threads were completed, and those 20 threads minus 20 threads, so 20,000 was deducted from the student bank account and 20,000 was deposited to the university bank account.